see.
I'm recording. I'm recording for a future. I can even send it to you at your free time to watch. Okay. So if the body's
Okay.
distance covered or displacement changes within equal time interval, what happens? So we are looking at time t is equal to zero. Motion hasn't started. So displacement zero. But let's assume that the change occurs within two intervals. Okay. So 2, 4, 6, and 8. If there is a fifth time, 10. Here what is happening? That the distance covered by the body changes within equal intervals. Okay, with equal intervals of time as well. Okay. Now when you plot such a motion, 0, 1, 2, 3, 4, 5. Then the distance 0, 2, 4, 6. There's a tunnel. So 8, 10. This is this distance or displacement. So 2, 4, 6, 8, 10. Okay. So let's plot such a motion. Okay. Let's plot such a motion. At time t is equal to 0, displacement is 0. At time t is equal to 1. So this is 1, 2, 3, 4, 5. At time t is equal to 1, the distance covered is 2. So this will be equal to, at time t is equal to 2, distance 4. Three, 6. Lady, are you there?
Yes, see.
Okay. At time t is equal to 4, distance covered 8. At time t is equal to 5, distance covered. Maybe what's the distance covered at time t is equal to 5?
10.
Good, 10. When you join such motion, you have a straight line. You have a straight line like this. Okay. We have the point A, okay, A,
Yes.
B, C, D, E, and F. If you want to find the slope, okay, Mark, how would you find the slope of this straight line or graph? So what will you do? You know, how you pick any 2 points. Okay, you pick any 2 points. So it can be A and B. Find the change in the vertical, change in the horizontal. So Bedu, help me find the slope of these 2 points you see, A and B. A and B. Bedu, that's yours. Help me find the slope. Then Immaculate, you have to help me find the slope of this point B and C. Kenneth, you are to help me find the slope between C and F. Did you get your task?
Yes, sir.
Okay, so start work. Within 1 minute, food must be ready. So for Bedu's task, this is the triangle for it. Changing the vertical over horizontal. For Immaculate task, this is a triangle, B and C. So change in the vertical over the change in the horizontal. For Kenneth's task, C and E, this is the change in the horizontal, change in the vertical. Bedu, what did you get for your slope? Mm-hmm.
Please, uncle.
Okay. Mami Araba. Mami Araba. The late Mami Araba. You can't hear me. Can you hear me? Oh, you are talking, but okay, your microphone is muted. Can you hear me? Mami Araba, then rejoin. If you can't hear me, rejoin. Okay. Bedu can hear me loud and clear. So, Bedu, what did you get for your slope?
Sir, I said I was confused.
Okay. Immaculate, what have you had for your slope? 2 Ghana cedis. 2 what? Okay. Kenneth, what did you get for your slope? Maria, if you can't hear me, I'll rejoin, okay? Okay, let's look at videos. So this is, you are looking for the slope between the points A and B. And slope is always changing vertical Y over changing horizontal X. And last time I told you, that is why in your school, you said Y2, this is Y2 vertical. So this is a change in Y. Y2 is here, can be read from here. Y1 is here and can be read from here. Okay. So, but what's your Y2?
Four.
What, come again.
4.
4. So 4 minus, and then Y1.
2.
Sorry, this is your A and B, between A and B. So this is for A and B, this is the change in Y, change in X. So what is your Y2?
Equals 2.
2, good. So 2 minus, what is your Y1?
0.
0. Let's look at the change in x. What is your x? X2. What is your x2?
1.
1. And then x1.
0.
0. Mami Araba, can you hear me? I want feedback
Yes,
from you.
please.
Yes, please. Yes, please. Okay, welcome.
Thank you.
You see, the reason why we attach units to the axis is to help you eventually determine the SI unit of your slope. Okay, so from here we have 2. But the vertical change in the x, what is the unit? M. Change in the t, what is the unit? F. And so you realize automatically, say slope is this divided by this, you realize that the unit of the slope will be meter per second. Okay, so that's why we attach units to this to help you. Bedu, Mamiaba, and Immaculate and Kenneth, are you fine? Okay. So Bedu's slope for A and B is 2 meters per second. Let's look at B and C, the task for Immaculate. So the same thing, this is your changing S, changing T. Immaculate, what is your Y2? 4. So 4 minus Y1. Then T2 or X2, 2. And then X1. So 2 on 1, isn't it? And what's it? 2 meters per second. Let's look at Gerard. Gerard's task is this bigger triangle. Changing S, changing T. So Gerard, what's your maximum, Mr. Gerard? What is the maximum Y value or S value? 10. Minimum. Maximum time value. 5. Minimum. So we have 6 on 3, giving us 2 meters per second. All right. Mami Abba, I hope you are following.
Pardon?
I hope you are following what you are doing.
Yes, please.
Okay. You see, because the slope is uniform, the same along the line or graph, we describe this motion as before that. Mami Araba, if you have a displacement, if you have a displacement time graph, the slope will be equal to what is it? Or we haven't done that. We haven't done that. Okay.
Please, the slope.
For a displacement time graph, the slope will be equal to. Maybe, do you have any idea?
Nothing.
Okay. So we realize that for a displacement time graph, the slope, which is equal to change in displacement as over the change in time. But what is velocity? Maybe what is velocity? Quick one.
So it's displacement over time.
So the rate of change of displacement, okay, with time. So when displacement changes with time, okay, then it gives us the result is velocity. So for a displacement time graph, this slope is also displacement over time, okay? And so this is equal to velocity. So what have we learned? What we are learning from this is that whenever you have, okay, let me adjust the screen up there. Whenever you have a displacement time graph, displacement or distance, let me say S dash T graph, slope is equal to velocity. Okay, for a displacement time graph, each slope is equal to the velocity of the body. And because when we tested, the velocity is uniform, the same along the line or the graph, we say this motion is a uniform velocity motion. Because when we determine the slope, it is the same along the graph or line. We say such motion is described as uniform velocity motion. Uniform because it is the same. Velocity because the slope of a displacement time graph gives us what? The velocity of the body. So uniform velocity motion. Please, are we okay? Mami Araba and Baby, are you okay?
Yes, sir.
Mami Araba, are you okay? Now, this slope is a positive slope. The slope or velocity of this kind of motion of uniform velocity motion. No, I wouldn't say for uniform velocity motion, but for this kind of motion, for this stated motion is positive. It means that this speed or velocity is what? A positive speed or velocity. When we measure, we had 2 meters per second for all. All right. Let's set another scenario. Please, Bedu and Mami Alba, are you done copying? So before we set another scenario, then let us understand what we mean by uniform. What is uniform velocity motion? I have somebody to try. Bedu, I want you to try. What is a uniform velocity motion? Bedu, try.
It is when the slope, like, they are the same.
Okay. Oh, you've tried. Mami Araba, are you there?
Yes, please.
Okay. Markley, I want you to try what uniform.
Please, I want to try.
Okay, Mami Araba, try.
Please, uniform velocity is when equal displacement is traveled through equal distance. I mean time, sorry.
Yes, Mami Araba. Mami Araba, when?
Please, I said that uniform velocity is when equal displacements is traveled in time with equal time.
Yo, nice try. Okay, so listen to it. A body is said to be in a uniform velocity motion. Are you writing? A body is said to be in a uniform velocity motion when the body covers equal distances. When the body covers equal distances within equal time interval. So when a body covers equal distances in a specified direction, okay, equal distances in a specified direction within equal time interval, then it means that the body is in a uniform velocity motion. Or a body is said to be in a uniform velocity motion when the time rate of change of displacement is constant. So I've given you two different definitions. A body is said to be in a uniform velocity motion when the time rate of change of displacement is constant. Or when the rate of change of displacement with respect to time is constant. Okay. So, Bedu, as we were looking at the motion, we saw that, yes, the distance covered by the body in a particular direction changes within equal intervals. Bedu, you see, it changes within equal intervals from 0 to 2, 2 to 4, 4 to 6, 8, 6 to 8, 8 to 10. And also within equal time intervals, 0 to 1, 1 to 2, 2 to 3, blah, 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 to 5. And when a body's motion is such that the body covers equal distances within equal time interval, then the body is said to be in a uniform velocity motion. Uniform because the velocity is the same along the line. And the slope of a displacement time graph is equal to what? The what? Velocity. And here, the velocity is positive. Let's quickly look at another scenario. We are looking at, this time we are looking at a scenario where the distance covered by the body decreases within equal intervals with time. So 10, 8, 6, 4, 2, and 0. The time is the same. Okay. Changing within equal intervals. 1 second, 1 second. Okay. Now, when you plot this, when you plot such a graph, When you plot such a graph or such motion, this is what you have. When time is 0, the distance covered is 10. So time 0, distance is. When time is 1, distance covered 8. When time is hold on, I'm coming. Hold. So when you plot this, okay, and I want you to finish plotting it. Mami Araba and Bedu, finish plotting it. So I've done so for 2. Okay. So when time is 2, displacement is 6. 3, 4. 4, 2. 2, when time is 0, when time is 5, the distance is 0. When you join the points, you also have a straight line. If you find this slope, okay, here is about the angle this makes with the time axis. It can be this or it can be this. But fine, angular measurement is taken this way. Okay. And in the other case, we have this. So the angle is here is acute, here is obtuse. Good. So when you find the slope, you get a negative value. Let's find the slope. Okay, let's pick any 2 points, and I will pick it. I won't leave that to you. Times it. I'm picking this and this. Change in the vertical, change in the horizontal, right? Good. Bedu and Mami Araba, are you there?
Yes, sir.
As for Zoom, if you are not careful before you realize the person is asleep. So change in the displacement, change in the time. Okay, so let's determine the slope. For the vertical, change in S and change in T. Look, what is the final? The final distance covered. Please, this point, I picked this point and this point. So for the distance, it means this is the initial. Okay, then it reduced progressively to rest, but I have chosen this and this. Okay, so this is the initial displacement. This is the final displacement. But we are always looking for y2 minus y1. Okay, so this becomes our y2, whereas this becomes our y1. Do you see it? So y2 is equal to what is y2? 2, isn't it? For this point,
Come again.
Okay, I'll come again. We are looking for the slope. Okay. But what is the motion? The motion is such that at time t is equal to 0, the distance covered is what? 10 meters. Then at time t is equal to 2, the distance covered is 8. So it means that this is our initial distance. Initial distance, which, because this will be y1. Is that, maybe, are you okay? But I am choosing this point. Everyone say B and B, A, B, C, D, E, F. So, and E. So the 8 becomes my initial Y1, whereas E becomes my final.